Hi, my name is Ryan Buchanan, and this is my project, The Life Cycle of a Star for Astronomy 20.
This is a nebula. A nebula is a dark cloud of gas and dust, and is the first stage of a star's development. As this gas and dust swirls around each other, it is eventually gravity that will pull it together and start the whole process of it becoming a star.
So what exactly is a star? A star is born when light elements are squeezed under enough pressure for their nuclei to undergo fusion. Sounds simple enough, right? Alright, let's try it out. Okay, alright, I'm back. So here we have hydrogen, helium, and a whole lot of other little elements, miscellaneous, we call it. So I'm going to mix these together and add some pressure and see if I can create my very own star. I know, sounds a little outlandish, but this is why it's science. Gotta try. Alrighty, last element, and here. And start to apply pressure. So I'm applying the pressure. I already have the elements. Up, and bow. There you guys have it, a star. Now, if only the process of making a star was that simple, it's actually a bit more detailed. Still starts with pressure. And first you have the pressure on the interstellar gases and dust, and everything bringing those elements together to create the initial fusion. Now, once the fusion takes place, you have another force of pressure, which battles against the force of gravity. So these two forces of pressure meet together and maintain a star's stability. Now, there are two paths a star can take. You get the average star, which is similar to our sun, and you get a massive star, which is 1.5 to 3 times the size of our actual sun. So these two paths determine how the star will live and how it will die in the next few phases. Now the next phase is where things get interesting. Our sun, this guy, turns into what's known as the red giant. This guy. See, this guy to this guy. The star's core runs out of hydrogen and helium. At this point, the core contracts and the outer layers expand and cool off. So the inner core is actually getting hotter and burning hotter while the outer core is cooling. Meanwhile, our friend, the massive star, transforms into what is known as a red supergiant. Massive star, red supergiant. So with the red supergiant, this phase gets a lot interesting. As it runs out of hydrogen, mostly composed of helium, it starts to fuse helium into carbon. Then the core gets so high and dense that it will fuse the carbon into smaller, denser elements like neon, oxygen, and silicon. This leads to the development of an iron core, which is actually too heavy to fuse with other elements. This for the supergiant is the beginning of the end. It reaches its end while the star collapses upon itself at such a rapid rate it results in a massive explosion. This process compared to others is actually quite fast, and the process is known as going supernova.
The last stage of an average star, it expands out in the form of ionized gas that's ejected from old red giant stars late in their lives. This is a relatively short phenomenon lasting a few tens of thousands of years.
After burning out all of its fuel, what is left of the average star is a white dwarf, which is the hot core of the star. Surrounding it is the aforementioned planetary nebula. Its mass is like that of the sun, while its volume is like that of the earth.
Then we have neutron stars. Neutron stars occur when giant stars die in a supernova and their cores collapse, with the protons and electrons melting into each other to form neutrons. Another outcome of a massive star supernova is a black hole. A black hole is an event in where a region of space, the pulling force of gravity is so strong that light itself is unable to escape.
And that, ladies and gentlemen, is the life cycle of a star.